Okay, so there will be two parts. So the first, I'm going to talk about the digital analysis, and then I will bring some new kind of research, textual analysis in this domain, which some of you may know. So I will share that. We have what, until 10:30 your time, right, Professor Sujan?
Yes, sir. It's up to
Okay.
10:30.
Okay. So digital analysis, just the word itself means an analysis of digits. So what does it mean? So let's see. What I'm going to do, I mean, this digital analysis is used for detecting unusual patterns. So it uses distribution of digits to find abnormality in the data set. Now, those who are attending the workshop or this presentation, I will provide a set of slides to Professor Bizu, and he can share with all the participants. So you don't need to worry about writing down the notes. I will make it available to you all. Okay. So that is what basically it does. It look at the distribution of digits in numbers that accountants use. And if there is an unusual pattern, what can we find from that? That's the basic philosophy behind it. So you can use two benchmarks to look at the distribution of digits and any unusual pattern. One is the Benford's law, and that is what I will spend time on it. And the other one is the past data. You know, assuming there was no error, last year data, if you look at the distribution of digits, how does it compare with this year? Specifically, this was used during the kind of a crisis period around 2000. They call it 2K problem. All these computers had programs that they didn't realize that they will have to worry about 4 digits number. So it was 1997, but you just had 97, whatever that was for that particular century. So when year 2000 came, the whole world was concerned that everything was going to fail. The planes will crash because the airlines will have their system which they cannot handle the 2000 year. And so one suggestion was that, all right, after you make changes, look at the pattern of last year and look at the pattern of distribution this year. And if you see that the changes are similar, or at least the pattern looks similar, that means everything went okay. The change that we made for this year, it's in line with what we did last year. But Benford's law is a theoretical concept, and so it is used to process inefficiency in certain cases. If there is a problem with internal control, you can look at the distribution of digits, and if it looks like unusual, you can identify the pattern and look into the actual transactions and see what is the problem. It is used to detect fraud, errors, biases, in circumventing internal controls. Internal controls may have some limits on individuals, how much they can authorize. So if there's a purchase of $100,000 and the sales of, our acquisition officer or the person in the department of acquisition, they cannot approve $100,000 of purchase. But what they can do, that divide that purchase into multiple times, 10,000, 10,000, 10,000. So in 10 different purchases, they can achieve that 100,000 goal. But when they do that, they will round off numbers in such a way that there could be a bias. And so if you plot those patterns, you may be able to find. So that is where it is suggested. And some background on Benford. I think he happens to be, again, a physicist, interestingly, 1938. So Frank Benford, a physicist, discovered that the digits of naturally occurring numbers, such as death rates, area drained by rivers, population of cities, and many other phenomena are distributed in a predictable, non-uniform manner. because sometimes we think that some of these naturally occurring numbers, all the numbers will be equally likely, but that is not so. So he developed a theory, and seems like he came up with a distribution that it follows certain logarithmic distribution. And I think in mid-90s, one person who was a researcher in accounting, and he is the first one to propose that Benford's law looks like accounting digits follow Benford's law. And if there is a fraud or any kind of manipulation of numbers, it doesn't follow Benford law. And so one can detect abnormalities or unusual pattern using this. And so here is a simple law that it follows. So distribution of first digit. So you look at the first digit, suppose 145. So the first one is 1, and then 4, and then 5. So each of those have certain distribution. So the first digit, D1, will be distributed with this probability of having a first digit, let's say D1, is log of 1 plus 1 over D. So if I say that I want to see how frequently 1 appears, it will be log of 1 plus 1 over 1, which is log of 2. So log of 2 is 0.3 something. So that is how the distribution of first digit. Then the second digit, or distribution of second digit, D2, is this sum, because 2 digits will be, let me first go through the 2 digits. So distribution of 2 digits, again, like 23. So the first digit is 2, second digit is 3. So it will be same distribution, log of 1 plus 1 over 23, or log of 1 plus 1 over D1, D2. So that's, and 2 digits can go from what? Well, 1, 0, that is 10 to 99. 9 is not a 2-digit number. And so this is the probability of D1, D2, that is first digit D1, second digit D2, that is log of 1 plus 1 over D1, D2, which is the same formula. If you say D1 is the digit 1, I can replace that by 2 digits. So you don't have to put too much effort in terms of what the formula is. But this one here, probability of second digit being D2, well, the first digit could be all different numbers. And so that's what, according to probability theory, if I have a joint distribution, probability of D1, D2, that is 2 digits, I can sum over the first digit to get the second digit distribution. That's what in this formula it is. Probability of D2 is sum of all the first digit. So the first digit could be 1 or 2 or 3 all the way to 9. So I write this formula, log of 1 plus 1 over D1, D2, and sum over all the 9 numbers of the first digit. So you will have first term, log of 1 plus 1 over 1, 0, plus log of 1 plus 1 over 1, 1, and the same thing, 1, 2, 1, 3, all the way to 99. And so that is how this will be found, but depending on D2. So if I fix D2 to be 1, then it will be 1, 1, 2, 1, 3, 1, 4, 1. If I say first second digit to be 5, then it will be 1, 5, 2, 5, 3, 5, because the first digit will change. So that's how that will be. Now, conditional, you can play around furthermore. So those who are looking for new opportunities, I have not seen much publication on this, but you can also condition it, that what is the probability of first digit D1 when the second digit is D2. So that means I can look at all the probability of first digit being 1 given the second digit is 5. And so that is where then I would have to use some kind of a conditional probability. Now, this one, same thing, just opposite. What is the probability of second digit being something given the first digit being D2? So all different kinds of distributions. So here is a simple distribution of the first digit. Just compute that, log of 1 plus 1 over D1, where D1 changes from 1, 2, 3, all the way to 9. And this is the number you get, 0.301, 0.17. So that means what it says, that first digit 1 will occur 30% of the time. And second digit appear about 17.6%, and this goes down 12.5%, and the 9 will appear only 4.6%. So it's kind of a distribution of log. And if I plot that, now interestingly, when I started working in this area, I wanted to develop a tool for me to use in the classroom. So actually we developed it and published it, and the technology is available. I think it still works. It's published in accounting education, issues in accounting education in the USA. American Accounting Association published it. So you can search for that paper. So I got hold of 3,000 transactions of accounts payable of a big major company in Kansas, not Kansas, but close by, Nebraska. And so I got 3,000 actual transactions. And I plotted that along with the theoretical distribution that you saw this earlier here. And look at that, I couldn't believe myself that how close the two distributions are. Actual theoretical distribution, you can see, is just incredibly close. Now, one can develop, so there is a test developed, chi-square test. You can take the difference of each of these individuals and perform a chi-square test and see if that tells you that these two distributions are very close to each other, or if there's a big difference, then you go and investigate on those axes. Actually, accounting firms has developed their own tool, a little bit more sophisticated with a lot of whistles and bells and all that. But they are using it because it is like a filter. Actually, Ernst & Young, I know they call it digital filter. So any data, suppose you have accounts, receivable transactions, maybe 100,000 transactions or 200,000 transactions or a million transactions, depending on the size of the company. You take the data and let it go through the filter, and you identify some abnormal behavior, and then look at those abnormalities and see what is the reason for it. It does not necessarily mean that there was a fraud committed. Maybe the nature of transaction is such that there is a peak at that particular transaction number, because that number repeats again and again. So this is the first digit distribution. And here is actual data for 2 digits. So same data I used, which is the real data of 3,000 transactions of a company. And I plotted this theoretical data, that's the black line, and then the purple line is the actual data. So you can see there are some blips around maybe 16 and then 19 or 20, but on average, it follows the pattern. So incredibly very close to the actual theoretical distribution. Now, I got another data from one of the major accounting firms that was investigating fraud. And the fraud was committed by these garages or the service station that fix cars. So this was a car rental company. And car rental company, they found that in certain location, there were a lot of cases of accidents reported. And they found out the number of cases that were reported were a lot more than what the police record showed. So they suspected there is a fraud, but who was committing the fraud, they were not able to really isolate. So they gave task to one of the big accounting firms, and they were doing it. And so while they were using what you call rule-based technique to detect fraud, and I was just working on this at that time, technology, I said, well, why not you give me the data and let me play around it. And so here is, okay, before I go there, here the distribution of second digit. So second digit, I can see if the second digit is 0, the first digit could be 1, 2, 3, 4, all the way to 9. So I'll have to sum over all such probabilities. So the first term will be 1 plus 1 over 1, 0, then plus log of 1 plus 1 over 2, 0, plus log of 1 plus 1 over 3, 0, and all the way to 9, 0. And so that is this number I have here, 0.1197. And same thing for 1, I had to sum over all that numbers. And so it will be, second digit is 1. So the first digit could be 1, 2, 3, 4, all the way to 9. So I'll have to sum all those, 9 terms, log of 1 plus 1 over that number. And I do that number and plot it. So this is not a sharp decline, but you can see still, theoretical one is slight decline, but not as much as the first digit. And then I plotted the actual distribution of second digit, and you can see that again, very close distribution. And to actually validate it that they are same or very similar, you'll have to use a chi-square test. So look at the distribution, difference of each of those bars, and then square it, sum it, and perform your chi-square test to see if it is significantly different. Now here is the data that I told you about, the fraud data. So purple line or pink line is the theoretical distribution of 2 digits, and the black line is the actual data. Now you can see very sharp peak around 16, and then another one around 25. Now what happens that the nature of transaction is such, since this was a rental company, and anytime if there is an accident of the car, there will be appraiser from the insurance company to appraise that particular damage, and the fee was $16. And then that car will be sent for repair. So what was happening, that the person who used to appraise, he was colluding with the service station. So he will appraise, charge his appraisal fees, and then will send to the service station for fixing the car. And so that's why this peak is there. But the nature of transaction, of course, it is 16 because of the appraiser. But the problem was that there were a lot of different appraisers who were appraising this. Some were doing it the real job, and some were just faking it. So who were faking it? How do you find out? So I did the digital analysis. So I had the data not only for digits, but also all the names of the persons who appraised the accident, the damage, and then the corresponding the service stations they took it. By sorting it out by name, I found that some individuals had a lot more appraisal done than some of the other. And also there was a time when that person joined the job, and so there was a time frame. So some person who was there only for 6 months had a lot of these appraisals, and some had many years and still they didn't have as many. So when you look at the individuals and also the area where the accident was happening and was being repaired, you could guess that this person may be the person who is committing the fraud, and the service station that is close by in that area was doing this. And sometimes what was interesting that they had also the specific car information too. So it seems like the same car was being repaired for the same problem multiple times. All these things led me to find out that who was the problem. So I contacted the person that I got the data. He said, so I told him that, well, my digital analysis tells me that this probably is the potential guy. He said, Raj, yes, you found it because we were able to capture it through a rule-based system, and that person was prosecuted, So this is how you can see. So you can program it. Actually, you can use the basic programming in Excel and develop an interactive systems and all. But this is being used also in the big data framework. You can have millions of transactions and look at the patterns and identify where the unusual behavior is. But remember, you have to look at the nature of transaction. I mean, if you look at the, let's say, you have in India, United Postal Service or UPS. Well, they have fixed rates. This many ounce, this much dollar, this many ounce, this much dollar. And so if you try to plot their transactions, the distribution, of course, you will have peaks at those numbers. So that does not necessarily mean that there was a fraud committed by them. But if there is some unusual pattern, of course, you may like to see if something is there that worth looking into it. And so that's how the auditors are using. So what I'm going to do is do some hands-on experience so that you can play around. So there are some Excel features or functions that you ought to know. So I have the data, and I'm going to show you some hands-on experience so that you can play around. You can have your access of your own data from any company and play around it. You can use it in the classroom to teach your students. It's pretty exciting. And also the paper you can get from the internet, and I can provide. So this here, the functions, value function, left, it gives you the left digit, first digit. So that is your first digit. So if you just use left and the address of the cell and the comma 1, that gives you the first digit, but that is just a character. But you want to change into a number, so you have to put a value function. So equal value left cell number comma 1 yields you the first digit. If you have first two digits, so put comma 2. If you have the right digit, means I want the second digit. So you'll have to have this operation. Value, give me the right digit first of this number, which is in the by this left cell number 2 digits. So these are, I think I'll look at it, and then count. I want to count all the cells, how many of them have digit 1. And this will be something that will be important. So I will show you now. These are some references that Negrini I mentioned to you. He is the first one to identify and work. So this is the publication in 2000, Digital Analysis using Benford's law. And then, I published this paper, Issues in Accounting Education, I mentioned to you. This is for educational purposes. It's used in the classroom, plus also we have a software. Mark Negrini continued his research. He published another paper for auditors in Auditing Journal. This is one of our prestigious journal in auditing field. Negrini again published in area of tax. I think this is pretty interesting. You might try to see in Indian data, just to have a research paper. So he found out that, taxpayers, how they avoid paying taxes. And so they round off numbers or, manipulate their incomes and round off somewhere which is not randomly occurring numbers. And so he found out that you can actually detect fraudulent behavior in tax avoidance area. There's another one here that, again, applying digital analysis using Benford's law to detect fraud. So these are all interesting papers. This is again published in a top journal. This is Auditing, a Journal of Practice and Theory. So these papers will be very helpful for you to not only just use in the classroom, but also continue your research in this domain. And the tools are already there. So let me now show you some hands-on kind of a tool, very easy. So I have two sets of here Excel. So first one is the data. So this is the data. I can make this available to you all. So digital distribution. I have 3,000 transactions. The one I told you that accounts payable given below from for the following tasks. So there are 3 tasks I require students to do it. Plot a graph of the distribution of first digit. This is the basic. This is where you find your abnormality in the data. Or the second one, same thing. Third one, so all different kind of first digit. first two digits and the second digit. So these are the three. I didn't try the conditional probabilities. You can play around with that. And, so not only you can use this tool for a classroom, but also you can do some interesting research, So here is the 3,000 transactions. You can see 315 is first transaction, 1,329, 225. So all these numbers, it's actual real numbers up to 3,000. So 3,012, you see, and from here it is 313. Now I want to see the first digit. Let me first remove it. Well, so actually I have copied it already. First digit here. See the formula, it is saying value, bracket, left, and bracket A13. A13 is this. And then 1 and close bracket, that's 3. So I repeat this, copy it, and 3,000 times, and in a matter of seconds, I got the data. The next one is this one, which is first two digits. And so for that, I say, give me the left of this cell, 2 digits. So value left A13, comma 2, and then I copy this and paste it. All the way. There is a quicker way. I forgot now. I think you can press key and get all the end of the data, but 3,012. So paste that. So I got that. And let me also get the second digit. So the second digit formula I mentioned, value, and then right of these 2 digits, which is left A13, 2, comma. So 2 ways I can do it. Since already I have the first digit, I can use the right operation and say, give me the right first digit from here. But I'm going to the original cell A13 and getting it. And I can do that by copying and then again pasting it to the entire set. Let's see. Okay, now, I guess anyway, that's fine. I think I have the number, so don't worry about it. Now I have to count. So the count, so what I create a table here. So you have to have digits that I will need it. So I want to count this digit. So I have to have a bin where I have the digits. So I'm counting digits from 1 to 9. So I will create this, column. So 1, 2, 3, all the way. I just type it in, and I put the formula in the count. So the count, I have the column A13 to A2012, and there's a formula I mentioned, count if, and then the entire array column. Put the dollar sign, so when I copy, it doesn't change the address. So $B, $13, colon, $B, $312. So that is the entire set, comma, 1. Well, this 1, actually, I can change this to this address. And so now I have a formula that I can copy. So now I'm saying, count the entire set for the number that is in G13, and G13 is 1. So this is the count for G13. Now I will just copy it and paste it. So I got all these distributions. So that means says out of 3,000 numbers, I have 985 times 1, and then you can say all the way 125 of 9. Let me sum it up and see what happens. If I didn't make a mistake, guess what it should add to? 3,000. So I'm all right. I didn't make a mistake anywhere. Now, actual. So actual is what? Well, it tells me that 985 times is 1 out of what? Out of 3,000 transactions. So what I can do, I can put a formula, divide this by this number. But F22, I have to fix that cell. Otherwise, it will be changing when I copy. So I'll fix that by $F $22. So now this is saying that the actual distribution is F13 divided by F22. I can copy and paste for the rest of the cells. So now I have all this. You can see number 9 appears in the real data 4%, 4.16%. If I sum it up, what do you think I will get? Can you make a guess? 1, of course, because these are probability of all these numbers, and these are the numbers possible, and so this should all add to 1. Now theoretical. Well, theoretical, we already did that, is saying that log of 1 plus 1 over the number. And I can use this address G13 because that is 1. So I can copy that formula to all the cells. Now this one is not right, because this will be copy this and paste here. So sum of those numbers again 1. So this is the table now we have created, where you have the actual distribution and theoretical distribution. This is what you will do in any situation. You have millions of transactions, same thing, except the accounting firms have used their expert programmers to make it a lot more fancy kind of a display. So here is the solution that I have it. So you saw that same table here. Let me kind of enlarge it, view it maybe 150, a little bigger. So these are the numbers. Look at that. This is the distribution I showed you in the slide, but this is actual graph that you can plot. Take any data from any company in India and try to plot it, and see sometime even errors and see if the students can detect it. So that is the 2-digit distribution. And then same thing I did for the first digit, and this is the second digit. So second digit, I have a column with the 2-digit numbers 10 through 99. I have to create that. So once I create this column, then I will count using the same formula that I showed you, count if that whole set of column that I created in C, and then using this P14. P14 is this digit 10. So I'm looking at how many times 10 appears, how many 11 appears. And so this is the data. Now, 2954. So you will wonder what happens. Well, some of the numbers seems like have some errors there, so it didn't capture. Then actual distribution and theoretical distribution, again, I use that and plotted it. And look at the plot. This is the data you saw. Such a wonderful distribution, okay? That's the distribution. In a matter of seconds, you get it. And this is the 2-digit distributions. Same thing. I created a bin or column of second digit. Second digit could be 0 through 9. And then I count using the same technique, that count the second digit column for these numbers, and then get the actual distribution and theoretical and plotted it. And this is the plot for that. So one can use it. And in the assignment, actually, I have another assignment that is there. I'm not going to spend time on it because I want to go and do something else. I have, I guess, 10:30. So how much time do I have? I have still
It is only 9:15 here.
So about
you can,
45 minutes or 40 minutes, right?
Yeah, 40 minutes. 40
okay.
minutes.
Okay, good. So this tool we have developed where students can do some kind of interesting study. They will type in by hand some numbers. I think assuming that they are using these 3,000 transactions. So in the assignment, we tell them that something from few dollars to maybe $3,000 or 4,000, type in some 30 transactions. And then compare that, their distribution with the theoretical distribution. And pretty interesting, if they have not remembered the frequency distribution or theoretical distribution, if they are cooking up numbers, that number will not come in accordance with the theoretical distribution. So it will not be like this. They may be more frequently typing 5 more than other numbers. So there may be a peak of the actual. So what the purpose was that if somebody is trying to manipulate numbers, they may not follow the pattern Benford's law. And so that's the part of the exercise in that. But this is another exercise that I use in the classroom. So that is. So any question before we move to the another part of the presentation?
Hello, Professor.
Yes, any question I have for this before I move to the digital distribution, because that's another area of exciting things that can be happening.
Professor, it was a good session. I would like to ask a question.
Yes.
Professor, you have clearly mentioned about the digits, how first digit, second digits can be identified, the manipulations. So Professor, if it is a minus number, or it is a negative number, or it is a decimal number, or it starts with 0, how we will identify the first digit? Based on this, it is.
Yeah, the decimal numbers are part of the last digit. So the first digit, if suppose you have 123.01, so that first digit is 1, second digit is 2, and third digit is 3. So it is going to look at from the left. Okay, and of course,
Yes.
the negative numbers, what you can do, I will say that isolate all the negative number and then look at the distribution, because you cannot merge negative and positive in the same system. It only looks at the absolute value of the digit. So suppose you feel like there's a lot of negative transactions, isolate them, sort them out, and then look at the distribution of that and find out. That is how I will do.
Okay, Professor. And like in an example, 0.58. So just start with 0. So how it will?
Well, one thing you can do, you can make it all new, multiply that by 100 or multiply by 1,000. So then you can still work that way.
Okay. Thank you.
Mm-hmm.
Thank you, Professor.
Okay, anything else? If not, then let's go to now look at some more exciting things. Okay, so let me open up my other slide. Okay. Can you see my slide?
Yes, sir. Yes, it's visible.
Okay, very good. Okay. Okay, so this presentation is titled Textual Analysis of Corporate Filings. What can we learn? The session tomorrow, I'll talk about the fraud triangle. That is a lot of things that have to deal with how the fraud is committed, why it is committed, and all that. But this is a new paradigm of research. It is becoming very popular these days in the US and actually globally, and in India. I think I have a couple of publications in Indian journal, I think Indian Accounting Review, that talks about this, but I have not seen many publications yet in India. Basically, what this comes from is the concept coming from psychology. Two researchers, I don't know, some of you may know, Toversky and Kahneman. Toversky and Kahneman were two, psychologists, professors at Stanford, and they have done a lot of work. They got Nobel Prize in this research area, decision making under uncertainty. But they also talk about the behavioral aspect of what people say and how they say it. And so if you look at the management report, say annual report, what management says not only is in accordance with the regulations, but also it portrays their personality, how they say what they say. And especially if somebody is manipulating information, they might say one way compared to a person who is not manipulating information. I will show you some examples, like Enron, if we look at their annual reports, they were hyping up the stockholders and potential investors all the way to the end when they even went under. Everything was just great, very, very bright. So there is a misrepresentation of information the way they say it in the report. So even though right now regulatory agencies are trying to control that behavior, asking them to disclose everything, but still they may not disclose certain things, they may not say everything, but at the same time also, excuse me, they may say in a different way. And so that is what this textual analysis is. So let me quickly go through. Textual analysis, some analytical geometry and textual analysis, risk assessment models. Then I'll demonstrate the technology that in the introduction, it was mentioned in conclusion. Here are some of the textual analysis. What does it mean, textual analysis? Well, the simple textual analysis is just the number of words, the word count in a document, or sentence count in a document, or phrase count in a document. Now, you may wonder, how does it matter? Well, there have been studies right from the beginning, actually, I think 80s or early 90s. The reporting, the size of report is becoming big. So from few thousand to now, documents are 90,000 words as big. So what does it mean? If somebody wants to communicate something, if they explain things in 1,000 words versus 100 words, which one easier to follow? And so that is one, but also at the same time, sentence. Sentence could be very complex. They may be using very, complex words. And so based on that complexity of the words and number of words by sentences and number of words in the whole document, then comes readability. Means who can read it and understand it. It's again a very fascinating field. I came into all this area because of the technology that when I became Ernst & Young professor in 1995, I had some funds available that I thought I will have a program where I invite visiting scholars from anywhere in the world and come and work with me, with us at the School of Business on common theme. And so since the center was Center for Auditing Research and Advanced Technology, I felt like, well, along with doing the traditional research, because that is something that we have to publish in top journals. But at the same time, I thought that we should develop a technology, and internet was just coming in. So I thought, why not we use the internet power to develop a technology where auditors can use it to do analytical procedures and using that audit process. And so this is how I got into it. And now it is a tool that a lot of schools globally using it. So readability indices is a measure of how complex the document is in terms of reading and comprehension. And that is based on the number of words per a sentence, complex words, all that makes it readable, or not readable. And it is very interesting because it came from Department of Defense in US. They wanted to have instruction manual written in a way that operators of these machines in a warfare situation can read it and operate the machine. So if the instructions are written that you need a college degree or a university degree, of course, that is complex because these people may be high school students or maybe only 8th graders who are operating these machines. And so they invited researchers to work on it. And now there are many different models that are developed on the concept of complexity of the documents in terms of the number of words, number of complex words, and number of words per sentence and all that. And very interestingly, some of them have come to normalize it that if the score is 6, that means a 6th grade person or 6th grade educated person can read it and understand it. And if the score is 16, that means you need a college degree, 16 years of education to understand it. And you will not believe, I have had some documents when I was doing this work on extensible business reporting language, and the instruction manuals or documents were written by computer programmers. And I had to read 3 times, 4 times. Still, I could not fully comprehend what they were saying. And so there are some documents that are complex. So these readability indices simply measures how difficult the document is. Then similarity matrix, again, very fascinating area. Similarity matrix means how similar two documents. Now, just you wonder, when you have one metric, one measure that tells you that I have 2 documents, maybe one company A, another company B, annual report, how similar they are, or how different they are. That is what this cosine measure is. And cosine measure means if you have any background in trigonometry, if there are 2 lines or 2 vectors, and if they're parallel, one on the top of the other, the angle between them is 0, and so the cosine 0 is 1. So that means they are very similar or maximally similar because the measurement of cosine 0 is 1. And if the 2 vectors are orthogonal, perpendicular to each other, then cosine of 90 is 0. So that means nothing similar because nothing common. Now the question is, how this works in the document case? Well, interestingly, each word can be treated as an axis. And so for each word, you can count how many times those words appear in a document. So then the entire document is a multi-dimensional vector. So if I have one document A, where some words appear 5 times, some words appear 10 times, some 20 times, some 1 times, those are individual axes. And so I can develop a vector based on that measure and compare another document, that similar vector, and compare the 2 and measure it, how similar those 2 are or how different using the cosine measure. And what is even interesting, that cosine measure is used in artificial intelligence and expert systems to identify objects. A simple example I'll tell you. They're using in image processing. Suppose my face. You take a picture of my face, put a coordinate somewhere, and then pixel. So all these different points in that image, you can have a vector representing my face with all these pixels and, measure of all the points that are distributed in my in that space. And suppose somebody is walking by with a CC camera and you have this technology there, you can take the picture of that face and again match that coordinate, develop that vector and match these two vectors. And if you find out 95% the same, immediately you might catch that person and start questioning if this is the person may be involved in certain situation. And so that is being used there too, the cosine measure. So you can see how these simple ideas can be so useful. Then tone of documents. That's again pretty interesting. Tone means what? Well, you have positive news about the company, negative news of the company. So that's positive tone and negative tone. The tone, so you can measure documents of the tone because somebody has already done the research and identified what are the positive words or what are the negative words. So you can take those positive words, count it, and say, all right, here is the tone of the document, positive. About IBM, let's say, look at that and say, well, what is the report says about IBM? Is it positive tone or negative tone? So actually there are companies in US, they're looking at the news articles and published in all these international journals or newspapers and trying to consult on positive tone, negative tone. And then some more work has been done, it is more recent, tone distribution, how that is distributed. And there's a lot more opportunity here as a researcher. If I have to disclose negative news in the news, maybe annual report, how should I distribute it so that I take advantage of the readers? Should it be disclosed at one time in the beginning, or the middle, or the end, or uniformly distributed? What about the positive note? Should it be distributed uniformly throughout? Should it be talked about in the beginning, at the end, and all that? So those are all psychological kind of questions, where you can influence your readers maximum, and that is how you are going to distribute. So this is happening already, so you can see if there's a negative news, how is management going to disclose? Where is it going to be, and how can we catch it? That's the tone dispersion. Tone dispersion means how is it concentrated and dispersed. Word variation from year to year. Our technology provides you how certain words change from year to year. So you can get 10 years of distribution of words, and I can identify it that certain words are not being used last few years that they have used, but now they're using something else. And maybe because I want to hide something, so I will change that. Or maybe I want to hype users, so I can use certain words that I didn't use previous years. So that comparison can tell me also about kind of manipulations. Already models are developed and tested and validated. Risk in general, and very simple model. This individual from University of Michigan, that was late, I think, or even around 2006, thought of idea that if company mentions risk, risk similar to risks, risky, uncertain, uncertainty, or uncertainty, only these three words, and of course, excluding some compound words or hyphenated word like risk-free or risk management, and then counted it and took the log of 1 plus that number and validated it and tested it that if certain companies are really risky, it shows in their document. And he has already shown that. I'll show you some examples. Then financial risk. Around 2005, in US, Security Exchange Commission started requiring disclosure of business risk-related terms and phrases. I think Professor Tattle mentioned it also that it is happening in India too. The disclosure of business-related risks. Like if somebody has risk about cybersecurity, they should disclose it. So the businesses are doing it. They used to do it voluntarily, but now it is mandated. It is required. And so 2014, 4 researchers tried to test this idea whether the SEC idea of requiring disclosure is working. So they identified 5 different risk areas. Financial risk means, is this company going to be financially viable, or is it going to be, it will have financial risk, well, go bankrupt. Then litigation risk. Would this company will have any kind of litigation, sued by users of the products or services or whoever? Then tax risk. Is this company paying taxes or avoiding taxes? This is a very exciting field for Indian researchers. Idiosyncratic risk means specific to that particular company. So what are some of the phrases and terms that you can identify risk is specific to that company? And then systematic risk, that is dealing with the economic environment. What is the risk in the environment? Like right now, COVID-related problem will be systematic risk. Everybody is facing. So what is the risk of in the industry? And of course, the fraud risk. So they used especially these 5 risks that I'm talking about: financial risk, litigation risk, tax risk, idiosyncratic, and systematic risk. Developed a regression model and dated it using actual empirical data. And we have programmed that because they published the list of phrases they used. Like financial risk, there are some terms that are used, like Chapter 11, Chapter 7, Chapter 9, all that are bankruptcy-related phrases. And so they came up with their own set of phrases that deals with financial risk, set of phrases that deals with litigation and tax risk and all that. And they developed the model. And of course, the marketing competition, I think that simply measures the competition one company faces based on, again, textual analysis. So this is actually just to show you how credible what we have done. This is a professor from University of Chicago, Professor Mike Minnis. He thinks what we have done is excellent. So he introduced me to a school in Paris. I was supposed to go last year to give a talk. So just the introduction letter. Hope, he said, hi, Peppa, she's a professor there. Hope all is well. Just wanted to make a quick introduction to Raj Srivastava in accounting admins, who started this company. This is the company. I thought I'll connect a few if you have any interest. I use Seek Edgar for both research and teaching. It is an excellent textual analysis tool for all sort of SSC documents. Very cool tool, and I have known Raj for several years. They have been subscribing the technology for last 7-8 years, and very strong supporter. A lot of cool things you can do. Here is another introduction by Bob Hurst. Some of you may know he's a former chairman of FASB, Financial Accounting Standards Board in US. He's a professor now at Columbia. And I want, again, going to Paris. INSEAD is one of the top schools in Europe. It's in Fontainebleau near Paris. So again, this person, professor, introduced me to Sharon. She's a professor there. Again, same thing. He attended my presentation at Rutgers and conference, and he was so excited. He said, Raj, I would like to introduction to INSEAD, and you should go and visit and give the talk. So I think I was just wondering, here are the schools that are subscribing, including, you can see Washington University, Chicago, Indian Institute of Management, Ahmedabad, Visakhapatnam. We have, along with that, a lot of databases that one can use for studying corporate governance, who is the chairman of the board of directors, all this, so I'll send you this material, so don't worry about it. So these are the models, textual analysis, I would say 6 of them, and 7th one is from an accounting professor from Northwestern. Basically, I was telling you the development model based on the average number of words per sentence, complex word, but the complex words were defined by multiple syllable word. So that's how it was defined. And so I'm not going to go through that. But what is even more interesting, that someone in accounting, 2017, you can see very recent publication, this group of researchers, they thought that, well, simply looking at the multi-syllable word may not necessarily be the complex word, because in business, we know what a company means. Company is a multi-syllable word. Litigation is a multi-syllable word, but we know what litigation means. And so they decided to look at what SEC had published, that businesses should report their disclosures in a plain English way. And SEC provided some guidance on plain English. So they used that as a starting point and came up with a list of words that they thought it would be complex, and then developed this measure called BOG index. And so they provide BOG index, and they published in 2017, Journal of Accounting and Economics. This is one of the top journals in the world. So you can see the value. So, our system provides those measures. So here is a simple, interesting example. Satyam and Wipro, I compared. Just curious to see how they are on a FOG index. Uniformly, Satyam was more complex than Wipro. And so I don't know whether Satyam had in mind that they may have to manipulate, but at least this is the observation. Again, on another measure of readability, again, Satyam was more complex than Wipro. Then I tried Enron. Again, look at Enron is uniformly more complex than Microsoft. Another measure, Enron more complex than Microsoft. This is the screenshot of our technology. I'll show you in a second. It just takes a few seconds. So it gives you a kind of a highlight of the key phrases and words if I search. And on the right-hand side gives you all these indices, the total number of words, total number of sentences. You can download in a matter of seconds all these indices. That's how I plotted it. Then analytical geometry, another aspect. So I was talking about the cosine measure. So cosine measure, I think those who are not too familiar, two vectors A and B, they have a direction and the size, and angle between them is theta. And I can measure the difference vector, that is C. So cosine of theta measures, how similar they are. That's what it is. So if they are one on the top of the other, it will be 1. And if it is perpendicular, then it is 0. There is nothing common. And here is the formula. I think you can see A vector and B vector. So take a product of two dot vector, divide by the size of the vectors. So I will not go into the details, you can know, but I will just show you conceptually what it means. And so here is what I mentioned, the each word can be an axis. And so I will identify all the words. If there are 5,000 words, some may be appearing few times, some may be 100 times, but they're all counted. And then I can determine the magnitude, and I can determine the product of the two vectors, and then compute the cosine. So here is the number. I say, all right, now one document just says 3 times litigation and 4 times penalty or penalties. Another document just changes the number. It says 4 times litigation and 3 times penalties. What will be the cosine of the two angles? The two vectors. Well, you can see the size of the vector is 5 for first one, and the second one is 5, because the size, you take the individual square of the axis each time, component, and add it up, and then take the square root. So here is 3 square plus 4 square, that is 25, and the square root of that is 5. And it so happened the second vector is also 5. And so I multiply that. So dot product, scalar product is element to element product. So 3 times first element is 3, and second one is first element is 4. So 3 times 4 is 12, and then 4 times 3 is 12. So 12, 24. So 24 is the dot product, and divide by 5, and times 5. So that is 0.96, 25 over 25, 4. And so the two documents in this case are similar with 95.6. So 96%. So maximum is 1. So 0.96, so close. So it gives you one single measure of how close two documents are or how different. And so, and it is used already for different purposes. You can see that, well, you can count, in fact, including all the numbers too. Numbers could represent an axis too, or without numbers, or without numbers and stop words. Stop word means a lot of times you have articles, prepositions, postpositions. These are really may not be significant, so you can remove them and do it. Or you can have your own specific phrase or words, and that is how they have developed these risk sentiment models, that counting just risk-related words or financial risk-related words or litigation-related words, and so all this use. Cosine measure, I think, is still a problem, because if I have 3 words like Adam eats fish, but if I change the position, fish eats Adam, these are the same 3 words. So the cosine measure of these 2 sentences will be 1, but they are not really the same. So there is a problem. But to deal with it, there is a natural language processor where you identify which is subject, which is object. So I think it increases the size of the number of words. Adam could be subject and object, and fish could be also subject and object. So you have, instead of 3 words, you may have then 2 plus 2, 4, and 5 words. So that can be managed, but still there's a problem. And I just published because I was trying to work on this, and I was curious why cosine measure is not working, and came up with a new measure, vector similarity matrix, and it is almost in the process of published. So these things being used, and like suppose you want to look at classify peer groups. So you can use description of your products and services, and see in the annual report which are the 2 companies where their report on products and descriptions are very close. So you can identify peer groups, you can identify mergers and acquisition candidates, a lot of this. Plus also there are some unusual behavior where you can detect fraud. And so that's where I want you to go. So here is a problem with the cosine measure. You can see 3 figures. The angle is same, but the 2 vectors, in fact, second vector B is different in each of these figures. First figure, the 2 vectors are the same, A equal to B in the size. But the second figure, B is 1.5 times of A. Third figure, B is 2 times of A. But cosine measure will give you the same measure of similarity. And that is what bothered me. It bothered me for last whole 1 year. And then all of a sudden I thought of the solution and came up, and then I said, well, even though I don't need a paper because I'm retired, but this will be something good that I should publish. So I wrote the paper and sent it, presented it at a conference, and they were excited that we never thought of this. And so vector similarity is based on the difference C. So C is B minus A. And so if C is 0, of course, B equal to A, no problem. But what happens if C is not equal to 0, but theta is 0, then it will give you a different measure of similarity. And so now A and B, since they both are textual documents, maximum angle between them will be 90, because you can't have a negative word. It's not a number. And so any document that is represented by A and another document B, if not a single word common, that means A and B are orthogonal, perpendicular. And so the measure is C between the 2, but I want to divide that by the value of that, which is from Pythagoras theorem, it is A squared plus B squared square root. So divide the C by that, and you have a measure called vector similarity matrix. And I will not go through that. I will show you some examples. You can see I have 5 examples here where angle same, but the size changes. So cosine measure gives always 1, this red line, but the new proposed metric, you can see changes for different situations. So if we look at the 0 degree angle, first one, you can see if it is equal, then 1 and 1, both measure gives you 1, identical. But If the size is different, if it is twice as big, then it is about 54% similar, and 3 times, then only 37%, is 5 times the 20%. So you can see how it's changing. It is more relevant. And here is something interesting. I measure that risk metric that you talked about, I mentioned earlier. Lee was the risk metric based on the risk, counting the risk factors. So you can see dotted line is the new measure that I'm proposing, and the solid blue line is through the already validated model by Feng Li. And they are so close, and the cosine is anywhere similar. So this is a bad measure. Unfortunately, this has been used for the last 20 years. Would you believe that? So especially in the textual context, cosine measure is not working very well to represent actual risk sentiments. Here is another example. This is a Bancorp. The previous example was Ford Motor, and this one is Bancorp. They committed fraud in 2015. They were kind. You can see how big is the peak. So the two methods, using the risk sentiment measure and my proposed model, you can see how close they are. And cosine measure that has been used for so long, nothing shows there. Okay, and our system here is another one that is showing. Let me see, skip it. Yeah, this is your fraud by Satyam and Wipro. Satyam and Wipro, cosine, not much structure, but new proposed model vector similarity. For Wipro, it is again very smooth, but for fraudulent company Satyam, it changes. There's a valley. And so this could be a symptom for unusual behavior. And I have looked at it, and since some people probably should look into a bunch of fraudulent company and see if this pattern be, So it will be like digital analysis. It will show you some unusual pattern just looking at the vector similarity. The word variation, you can see word by, here is a case. I have plotted 10 years of data and look at certain words like wholesale, deal, and broadband for Enron. Look at that. Wholesale changed from 0 in 94 to 52. Then broadband, 000, all of a sudden 27. Maybe they were hyping the public that we are in wholesale around the globe. We are using all this high-tech technology. So this is something yet to be done, but the tools are there. You can look at if somebody is manipulating, what kind of words and phrases they are using. Okay. Now, here is one, I talk about the Enron. Simple measure that I mentioned, counting the risk. You can see, I look at the quarterly reports. Risk is going up and up and up and all the way to the highest point at the year they went under. So I don't think they knew that they are telling the public that they are becoming more risky company. So you can, and this is the, all these 5 risks that I talked about, financial risk, litigation, all that. And this is the paper. And these are the different words and phrases. You can, here is one example. Hers committed fraud, and the year they committed fraud, 2014, you can see fraud risk is the highest. So this could be used, this kind of technique in textual analysis could be used to have a initial, like digital analysis, signal about something unusual behavior. And with that, I'll take another second or two to show you something cool. So here is the technology that I was involved in developing. Website is there. I have a few minutes of introduction, and this is the site. By the way, we will have Indian data. We are in the process. We hope that within a month we will have Indian data. We have a company helping us get the Indian data, and we are going to perform and on the same platform. So here is the data that we have right now. Right-hand side is all the data. We have 36 million documents, 36 million. And this on the left-hand side is the logic to search for. We can use Boolean logic. So if I say, let's say I want to look at COVID, how many documents mention the word COVID? I can have Boolean logic or coronavirus, these two. Well, coronavirus, I can look at all of them. Let's see, entire document, 36 million. Okay. And here is all the files from 94 till yesterday, and see what happens. Look at that. How many seconds did it take? And I got 296,000 filings from 94. Well, 94, it may not be there, but 219, I think. And it gives me the snippets of where that word appear, and it gives me the textual analysis here. If I just look at annual reports, then see what happens. Annual reports, again, a few seconds, it gives me, again, snippets, and you can see the textual analysis, all the reading indices and all these risks here. So you can download all these in a matter of seconds and then do the analysis. So what I showed you, I did it just a matter of hour or minute, Then something else, I think you can see, suppose I'm looking at bios of executives. So I look at the table, I find out the name and age appear next to each other. That means I will look at the proximity search feature, that name and age within two, look at, they are usually in table, and they are in this document, they call it proxy statement. Look at that, 89,000 tables, and so clean table. There is nothing like this, not Google, not anyone. So because this is coming from research, and when I realized it, and then started sharing with my friends, and anybody coming to KU, then they started subscribing it. So it is pretty cool technology. So along with that, you have a lot of things, compensation data. So we have been able to create also data, compensation data, salary and bonus appear next to each other. Even the Indian company, I can get it. And so what do I get? Well, again, look at the tables. And in few seconds, you get such a nice table. I can dump into Excel and create databases. There is nothing like that. Google cannot produce this kind of unique data. You will get a lot of junk. And so if you want to look at the cosine measure, you can see, it tells you. So you can see the difference of all these documents. You have item one where all the risk factors are disclosed. So you can measure the cosine measure and vector measure for all these documents. And we will have it also, hopefully for Indian data too, very soon. I think within a month we'll have it. So with that, I think my time is up. I want to open up for discussion. I can provide another session if any of you interested on this technology. This was simply to expose you in terms of what opportunities one would have using this kind of technology. So, question. I see. How do I get back to the? I don't see my. Do you see me still?
Yes, sir, we do see you.
Okay, so maybe I will stop sharing and then let's see. Yeah, okay, that's what it is. Okay, so question. My time is up. I have gone a few minutes beyond.
That's okay. But participants, you can either type in the chat box or you can unmute and ask directly.
Sir, actually, it was a wonderful session. You said about Davenport's law as well as the textual analysis. Both are very useful sessions, actually. But sir, this question is for my researchers. This Benford's law will give us an indication about this fraud. But what is the use of this Benetian score?
Well, what is Venetian score? Can you elaborate on it? Do you have the background on it? Because I think it may be a metric where you determine the abnormality through chi-square, and if it is beyond, the chi-square fit, that it is different, then you have to look at it. So that may be the measure where you found the theoretical distribution is different from the actual distribution. Then you need to go and look for it. So that may be a single measure where you already know that there is an abnormality. And so then you go and look into it. Like the example I showed you, that if I had to do the Venetian score or chi-square fit, and I will find that data that I had from this accounting firm did not fit the theoretical model. So I say, all right, no, it is abnormal. But then what do I do? So it provides you an opportunity to look for where the problem is. But you don't need to look at if it is not different. So if the score is very small, within chi-square fit that the two are similar, then I don't need to worry about it. Then I go beyond and do something else. So accounting firms use this as a filter. They call it, at least I know Ernst & Young calls it digital filter. So suppose you have millions of transactions of some credit card company, and you didn't find any abnormality. That means, you don't need to worry about it. But if you find any abnormality, then you might like to investigate where the problem is. So you look at all those digits where something happening. It may not necessarily be fraud, but you want to know why there's a abnormality. Okay.
Thank you, sir. Thank you. Actually, the tool you have familiarized, the secret, that also found to be very useful, because we are also interested in subscribing the same. So
yeah. So if you want another session for more closely in terms of, we can talk about, because this one, not enough time to talk about it. But I thought that I need to expose you because this provides new opportunity for research. Okay.
Yeah, sure, sir, sure. Because after subscribing the same, we will arrange a separate hands-on session on the same with your help.
Good, very good. Well, if there are no more questions, thank you. I will be happy to answer questions later on too. If anyone thinks about it, send me email. I think that will be fine. Okay. But I wish you all have a good next few days of the sessions, and I'll see you tomorrow at again 9 o'clock your time?
It's
yes,
9 o'clock. Yeah, and we'll take over the rest of this.
Okay, thank you so much. Okay,
thank you so much, sir. It was such an enriching session on digital analysis and textual analysis. As we have come to the end of this technical session, to officially express our gratitude for the session, I invite our research scholar, Anne-Marie Alexander, for the vote of thanks.
Thank you so much. Resource person for today's morning session, Professor Rajendra P. Srivastava, faculty members, organizing committee, and participants. A very fine good morning and good evening to all.